In this video, we're looking at calculating all 6 trig functions of any angle, even if it's not in our unit circle. And so in class, we started by talking on, this is the back side. On the first video, let me back up. We talked about secant and cosecant, how we can calculate those. And then I also left you with these. Again, if you have questions on secant and cosecant, please ask me in class, and I'll be happy to help you out with that. But in class, we talked about here we have an angle theta. We don't know what the actual measurement of theta is. We're just given that it's an angle, and that we have at the end of theta, it's going to this point 4, 3. And we talked about, like, it's not going to be on our unit circle. So we need to think about another way that we can actually get sine, cosine, and tangent. And the goal here is that we want to get sine of theta, cosine of theta, tangent of theta. And we're going to start there, and I'll just explain why. And what we talked about in class is that if we start here at the origin, if we were to graph this point, then this is telling us to move 4 units to the right, or in other words, that this length would be 4 due to the x-coordinate being 4. And then we would go up 3. So if we did that, then this is going to be 3. And we notice that, hey, we have a right triangle here. 4 is on our x-axis, 3 is on our y-axis. And if we could find the hypotenuse, then we could find these 3 functions using the trigonometric ratios that we know. And we can. We could find the hypotenuse using what's called the Pythagorean theorem. Hopefully that's familiar. So we can say a squared plus b squared equals c squared. Simplify this. Take the square root. And c equals 5. So here, that means that 5 would go here on our hypotenuse. And now we have all 3 sides of our triangle. We know that theta is this angle here. And so now we can calculate sine, cosine, tangent of theta. If we're looking at sine of theta here, here's our angle. Sine is going to be opposite over hypotenuse. If it helps you out, you could do SOHCAHTOA. So sine is opposite over hypotenuse, which means that'll be 3 over 5. Cosine is adjacent over hypotenuse, or 4 over 5. And tangent is opposite over adjacent, or 3 over 4. So these are our main 3 trig functions. But in this problem, it's asking for us to calculate all 6 trig functions. But in class, we talked about if you can get these 3, that's great. You don't need to remember that secant is hypotenuse over adjacent. You don't need to know that. I don't generally remember that. But what we can do is say sine. Now that we have these 3, sine is going to be related to cosecant. So as long as we know this, then if sine is equal to 3 over 5, then cosecant is going to be 5 over 3. Cosine is related to secant, which means if cosine is 4 over 5, then secant is 5 over 4. And you kind of get the picture. Cotangent, if tangent is 3 over 4, then cotangent is 4 over 3. And so those are our 6 trig functions, all coming from the triangle. Now I want to make a mention that some students said sine of theta is 3 because cosine is x, sine is y. And that is true only on our unit circle. Because what's happening here is on our unit circle, the hypotenuse was always 1, which is why really in the ordered pair, it would be 3 over 1 because our hypotenuse is 1, which is why sine was always the opposite, or the y-coordinate. But here our hypotenuse is not 1, so we do need to take in consideration all of the original definitions of the ratios to actually calculate those 6 trig functions. Key difference, if that's confusing, please ask me about that, and I'll make sure I can clarify the difference between what's happening here and on the unit circle. Now, I'm going to talk about these 3. So here it was easy. The theta angle is here. This I'm just going to have to kind of say what's happening. If you have questions on why, we talked about this in class, but it's really hard to do it without having the unit circle handy and explaining it using that. But every time you're given a point, theta is this entire angle. But what we're going to do is, no matter where the point...
Teachers, well, it's a lovely Thursday. It's our third official enrollment Thursday.
Gotta love announcements.
You need to make sure you clear out your boxes this morning. We have a pink form.
I'm going to keep talking, though. No, maybe not.
Whether you have conference period or not, you still have to fill a form out. We need a form from everybody in the building. Thank you.
So no matter where our point is in the coordinate plane, we're always going to draw to make our triangle go from that point directly to the x-axis. Here, directly straight up to the x-axis. Here, directly straight down to the x-axis, always, to create our right triangle. If you have questions on why, I can explain that in class. And then we're going to use what we call a reference angle for theta. So really, and our reference angle will always be closest to the origin, closest to the origin, closest to the origin. So when we're calculating this, yes, theta is this entire angle, but in terms of our triangle, our reference angle is going to be the one that's closest to the origin. So if you want to take this triangle over here, then what's happening is we're looking at this angle because that's the one closest to the origin, the -8, -15. If I start here, I need to move 8 to the left, which means this top piece of the triangle would be -8. This side piece of the triangle would be -15. I'm going to let you try to calculate the hypotenuse, and I'm going to give you the first 3 and let you do the rest. If you calculate the hypotenuse correctly, then sine should be -15 over 17, cosine should be -8 over 17, and tangent should be -15 over -8, but a negative divided by a negative is a positive. We're going to continue working on this in terms of review on Thursday the 24th and Friday the 25th. But if you do have questions, please feel free to ask me through the Remind app, in class, email, or whatever other method that you can think of.